Hi everyone, I, Mrs. Lino, together with Ma'am Chodoro, will discuss with you about the integration of rational functions of sine x and cosine x. So at the end of the lesson, you should be able to evaluate integrals of rational functions of sine and cosine. So to learn how to evaluate integrals involving this function, so here is Ma'am Chodoro to discuss with you the step-by-step process.
Half-angle substitution is based on half-angle identity for tangent, and we are going to use this for integration of rational functions of sine x and cosine of x. And in here, we're going to have the substitution for sine of x, which is equal to 2u over 1 plus u squared. For cosine of x, we will have the substitution 1 minus u squared over 1 plus u squared. And for the differential of x, okay, we will have 2 over, rather, 2 times the differential of u over 1 plus u squared. Okay, let us illustrate this substitution in the first example. Okay, in here, we have the integral of the differential of x over 1 plus sine of x plus cosine of x. Okay, now we are going to do the substitution for sine of x, and sine of x is 2u over 1 plus u squared. Okay, then we will have the substitution for cosine of x. Substitution for cosine of x is 1 minus u squared over 1 plus u squared. And for the differential of x, now we will have 2 times the differential of u over 1 plus u squared. Okay. Hence, if we are going to evaluate the integral of the differential of x over 1 plus sine of x plus cosine of x. Okay, let us now have the substitution. Okay, for the differential of x, we have 2 times the differential of u over 1 plus u squared all over. Okay, we have 1 plus, substitution for sine of x is 2u over 1 plus u squared. And the substitution for cosine of x is 1 minus u squared over 1 plus u squared. Of course, before we evaluate, we have to simplify the integrand. And let us try to do it. Let us try to simplify the integrand. Okay. We have 2 times the differential of u over 1 plus u squared. And we can simplify the denominator by getting the common denominator. And the common denominator is 1 plus u squared. Okay. Now, if we are going to multiply 1 by the common denominator, that gives us 1 plus u squared. Okay, then plus 2u. Okay, so plus 2 times u, and then plus 1 minus u squared over the common denominator 1 plus u squared. And in here, we can cancel the denominators 1 plus u squared, right? And simplifying further will give us the integral of, no? In the numerator, we will simply have 2 times the differential of u over the denominator. Let us try to simplify. Now, we have 1 plus 1 is 2. Now, u squared minus u squared will give us 0. Then plus 2 times u. Okay. Now, please take note that we can still simplify. Okay, wait. Okay, we can still simplify the denominator by factoring out the common factor 2. So 2 times the differential of u over 2 times the quantity 1 plus u. Okay, and you can see that we can do cancellation again, no? We can cancel 2. Okay, so that the integral is reduced to the integral of du over 1 plus u squared. And you can see that the integral will lead to, sorry, it should be 1 plus u. Okay, sorry for that. Okay, let me erase that. Okay, so we have the integral of du over 1 plus u. Okay, and we can see that the numerator is the exact differential of the denominator. Hence, the integral will lead to the natural logarithm of the denominator 1 plus u, okay, plus the constant of integration. But we need to substitute back the original variable. So to substitute back the original variable, then since u is equal to tangent of x over 2, okay, then we're gonna replace u by tangent of x over 2. Therefore, the integral is the natural logarithm of the absolute value of 1 plus tangent of quantity x over 2 plus the constant of integration. Okay, so we were able to evaluate the integral, no, of rational functions of sine and cosine. Okay, now let us have the second example. This time, we are going to evaluate the integral of the differential of x over 4 plus 5 cosine of x. Okay, so again, we are going to have the substitution for cosine of x. Of course, cosine of x is 1 minus u squared over 1 plus u squared. We do not have sine of x in the integrand. Okay, and the differential of x is 2 times the differential of u over 1 plus u squared. And let me write here na rin that u is equal to tangent of x over 2 if we will substitute back the original variable. Okay, so if we are going to evaluate the integral of the differential of x over 4 plus 5 cosine of x, then this will give us integral of, we can replace the differential of x by 2 times the differential of u over 1 plus u squared over the denominator. The denominator is 4 plus 5 times the quantity. Okay, cosine of x is 1 minus u squared over 1 plus u squared. Okay, so we have to multiply this by 5 by 1 minus u squared over 1 plus u squared. And then let us simplify further. Okay, so this gives us integral of 2 times the differential of u over 1 plus u squared. Okay, and what about the denominator? Okay, we will have 4 plus, if we will multiply 1 minus u squared over 1 plus u squared by 5, that gives us 5 minus 5u squared over the denominator 1 plus u squared. Okay, and we can simplify by getting the common denominator. Common denominator is 1 plus u squared. Hence, we will have the integral of 2 times the differential of u over 1 plus u squared over, okay, common denominator is 1 plus u square. And if we will multiply 4 by 1 plus u square, will give us 4 plus 4u square, then plus 5 minus u square. So at this point, we can do cancellation. We can cancel the denominators 1 plus u square. No, please take note that if we will divide the numerator by the denominator, we have to get the reciprocal of the denominator. So that will mean that we can do cancellation for the denominators. And this will lead us to, okay, we can write 2 before the integral sign since it is a constant factor in the integrand. Okay, du over, if we will simplify the denominator, we have 4 plus 5 is 9 minus 4u squared minus 5u squared. This should be 5u squared, sorry. Should be 5u squared. No? Will give us u squared, right? So u squared. Let me make this clear para hindi mabasa masyado. Okay. Should be the main division bar, and we have 5 minus 5u squared, no? To make it clear. Okay, so 4 plus 5 will give us 9, and 4u squared minus 5u squared is negative u squared. And you can see that the integral will lead to arc sine. Now, a squared is equal to 9. Therefore, a is equal to 3, right? Hence, the integral is 2, okay, times arc sine of u over a, no? So u over a, so u over 3, okay, plus the constant of integration. And substituting back the original variable, now replacing u by tangent of x over 2, will give us the integral equals 2 times arc sine of tangent of x over 2 over 3 plus the constant of integration. Okay, so this is the integral of the differential of x over 4 plus 5 cosine of x.
So in summary, to evaluate integrals involving rational functions of sine x and cosine x, half-angle substitution of tangent function should be employed. So letting u be tangent x over 2, so we can derive these three equations as follows. Sine x is 2u over 1 plus u squared. Cosine x is 1 minus u squared over 1 plus u squared. And dx is 2 du over 1 plus u squared.